Good morning, sir. Myself, Aditya Rausab Tambe. Today, I am presenting the presentation on DC generator and alternator. So, I will introduce my project on and the definition of it. The DC generator, a device that converts mechanical energy into direct current electricity is known as DC generator, and the alternator, a machine that converts mechanical energy into alternating current energy, is known as alternator. The purpose behind this presentation is understand the key difference and similarities between these machines. Now I will be explaining the basic principle of DC generator. The for Farade's law of electromagnetic induction. The key component for this law is armature, field winding, commutator, and brushes. The further is types of DC generator. There are mainly five types of DC generator. First, separately excited DC generator, self-excited DC generator, series shunt, and compound means long and short DC generator. Working working of a DC generator. In a machine, the machine input rotates the armature inside the magnetic field. The magnetic flux engage change and induce an electromotive force means EMF, and the commutator converts the generated AC into DC. The basic principle of an alternator is key components. The key components of alternator is stator, rotor, slip ring. Working principle converts mechanical energy into alternating current based on Fred's law of electromagnetic induction. And the output behind this alternator is AC voltage with a sinusoid waveform. Now I will be explaining the types of alternators. Classification by excitation. Self-excite alternator, separately excite alternator. Types of rotor: silent pole and cylindrical rotor. Applications: power generators, vehicles, and industrial applications. Now I will explain the working of an alternator. The process for alternator is, first of all, rotor spin inside the stator's magnetic field. The second process is alternating current is generated in the stator winds, and third is the frequency depends on speed and number of poles. The further side is on difference between DC generator and alternator. Basically, I have shown the chart of features. Features means there are four features named as output, commutator, applications, and convergence. And the difference between DC generator and alter is given on our screen. So in output, the DC generator gives direct current, and alternator means alternating current. In commutator, uses commutator. DC generator uses commutator, and alternator use slip ring. In application, DC generator uses we have low voltage application, and in application the alternator has high voltage application. And last one, the conversion. In DC generator has AC converted to DC internally, and alternator generates AC directly. So the further slide is on application of DC generator and alternators. DC generators applications are battery charging, small power application, and alternator applications are large scale power generator, automotive alternators. The further slide is on advantages and disadvantages. The first of all, I will tell you the short in short the advantages and disadvantages of alternators. First of all, the advantages for alternator is efficient for large power generation and higher outputs. And the disadvantages for alternator is more complex, required precise regulation. Now I will tell you the advantages and disadvantages of DC generator. First of all, the advantages for DC generator is simple, cost effective for small scale application, and disadvantages for DC generator is limited to low voltage, required regular maintenance. Now I'm concluding my topic by some key takeaways. First of all, both machine works on the principle of electromagnetic induction. Second, DC generators are primarily for small scale applications. And third, alternator are widely used in high power generation and industrial applications. So thank you. I have this was my presentation for DC generator and alternator. Thank you.